right, continue 6.1. We're gonna take a look at an example. Oopsie. Concert attendance. The Peninsula Brass Band will hold a semi-annual concert in a community center that has seating a capacity of 500. So 500 seating is the maximum seating they have. The band expects that at least 200 season ticket holders will attend the concert, and at least 100 non-season ticket holders will also attend it. Write a system of linear inequality that give restriction on the number of each type of ticket holder at the concert. So we have to identify what kind of variable we are looking for. Number of each, let me make it a little smaller. Number of each type of ticket holder at the concert. There are two of them, right? Season and non-season ticket holders. So if I let X, if I let X, Y be the number of ticket holders for season and non-season respectively. So X is the season ticket holders, Y is the non-season ticket holders. So far, so good? Can someone come up with the first inequality?
100 X and 200 Y.
No. Inequality though. I need something less than, greater than, something like that. But thank you. Maybe just one at a time. Don't think too hard. I just need one for now.
100 plus 200 is less than or equal to 500.
No. What is the first inequalities? Should be easy. Yeah. Yeah, right. They have maximum is 500 seat, right? You cannot go over that. So XY is the number of ticket holders. So X plus Y, it should be less than or equal to 500. You cannot sell more tickets than the seat they have, right? So far, so good. Second one, the band expects that at least 200 season ticket holder will attend. They expect at least 200 season ticket holder. What does that mean? Yeah. Yeah, right. X is, so that means X is the season ticket holder is greater than, at least greater than equal to 200. Maybe I'll put it over here. And then the other one will be similar, right? Y is at least 100. And that is a system of inequalities that we have. There's another one. If Y is the number of tickets, then it can be negative, can it? Right? So there's another one. It's kind of trivial. We don't think about it, but practically just the other one is XY. It had to be what? Equal to 0, right? It just makes sense. You can't have negative ticket. You don't sell it. You don't sell it. So I only care about if XY is at least 0, then I only care about the first quadrant. Yeah. All right, let's graph the easy one first. X is greater than equal to 200. It's gonna be a vertical line or horizontal line? Yeah. X. I mean, vertical. I know it's horizontal, so it must be horizontal, but Yeah, I know, it's kind of counterintuitive. So if I gonna scale this first, so let's say let's shoot 100, this is 200, 300, 400, and 500. Did I note in blue here? Okay. So it's greater than 200 gonna be shaded to the right, right? I'm not gonna shade it, it's just too much shading. Y is greater at least 100, so again, I gonna scale my y-axis as well. 100, 200, 300, 400, 500. 500 is the maximum. Y equal 100 gonna be a horizontal. And because above, you're gonna shave it above, right? So the intersection will be what? No, don't shade this. Don't shade this. It's too much shading. It's messy. So shade that and shade that. So intersection will be this, right? This part. But I'm gonna erase it because it's too messy. The red one, the more complicated one. X plus y is less than or equal to 500. So this one I'm gonna actually write out. X plus y is less than or equal to 500. Remember with the step, we set it equal to, right? So x plus y is equal to 500. Use a little t-table, x, y. If I let x equal 0, y is 500. If I let y equal 0, x is 500. Okay, so 0, 500, 500, 0. Right there. It's easy enough. Oops, let me use the other one. We agree that the two blue lines make up for this part, right? So I know I don't shade it, but let's see about those part. Now we have to do what? Choose test point. Now you're gonna choose test point. So you know, should I shade it? Should I shade here or should I shade over here? So you choose test point. Let's choose. I'm going to choose. It's just I'm going to choose. Say 300, 400. Is that okay? Yeah, I'm gonna choose that one. Let me make it into different colors so you can see it. We're gonna use yellow. $400 for X and 300 for Y. That's point, right? When you plug in, you're gonna plug into the original. What do you think? 400 plus 300 is 700. Definitely not less than 500. It's false. So you shade what? You shade the opposite, right? Shade the opposite. You done? Like I said, the reason I don't bother to extend my little red line because I don't care about these, right? I only care about that. Any question from this problem? Last semester, and I think it's gonna be in any semester. We have a final exam. You have something like this, like inequality, story problem of inequalities. solution. All right. Was this? Question C. Assuming that the attendance will be expected, it is possible for season ticket holders and non-season ticket holders to attend the concert. Prove your assertion. Do you understand what the question is asking you? That's the problem. You can understand the question asking you. Assume that the attendance will be as expected. What attendance? Like you look back to the question, like what attendance they're talking about. The band expected at least 200 from season ticket and 100 from non-season ticket. So as expected, the 200 and 100. The question is it possible? Is it possible for season and non-season ticket holders to attend the concert? Yeah, 300 and 200 plus 100, 300, right? You still have a bunch of seat left, right? So yeah. Remember, the word as expected. 200 plus 100 is only 300. Still less than 500. So yes. The last slide, we're done. So once you graph your solution set, the solution set of a system linear inequality is bounded if it can be enclosed by a circle, otherwise it's unbounded. So let me give you an example of bound or unbounded. Excuse me. Excuse me. Excuse me. So there, bound versus unbounded. Yeah, I don't care about first quadrant. So bounded means what? It's been enclosed into a shape, right? You can put it in a circle. Where unbounded means your solution set have no bound, right? It's go to infinity. You see on the second image. Right? There's nothing to stop it. Okay, so you know bound and unbound now. Right now, take a look at the example. Definitely this is bound here, right? Right system linear inequality that describe the shaded region. Why don't you guys try this? So in the little square box, I want you to put inequalities. Is it less than, greater than, less than equal to, greater than equal to? Anyone? Okay, the last two should be easy. It'll be what? Okay, everybody can do that one, right? We're interested in the first quadrant. How do I determine which line is which? And that's from 661. This should be easy. Let me put this in blue. Black for that. Okay, which one is the blue line? Can someone tell me which one is the blue line?
Is it the one that crosses at 6?
Yes, right? The 16, 6 and 15, right? Oops, blue. And then the other one must be red. Right? So all you have to do is just use in your little t table, right? What happened when x equals 0? What happened when y equals 0? What do you think? For the blue line, 5x plus 2y is going to be what? 230. You can pick a test point, right? Pick a test point. What's the answer? So all you do is pick a test point, right? Let's say pick 2, 2. 2, 2 right here. You plug it in, right? So say 2, 2, 5 times 2 plus 2 times 2 is equal to 14, right? That's less than 30. Less than or equal to 30. So because it's solid line, so I know it has to be equal to. So you know less than equal to. And you do the same thing for the second one. 2 plus 3 times 2 is 8. It's also less than or equal to 18. You done? How easy that is. All right. Do
Why
you
did you
have
set
any
it
question on
to
it?
less than?
What?
Why did you set 5x plus 2y and x plus
Oh,
3? Why did you set it?
because Test point, test point, test point. I need to know what side I'm going to shade, right? So, well, I know that I shade this one. So I'm gonna pick a test point, 2, 2, see what happened. Is it gonna give me in less than or greater than? And when I plug it in, 2, 2, it turned out to be less than. Then original inequality should be less than or equal to. Does it make sense?
Yeah.
Yeah, all you do is just pick a test point.
So if I picked like 10, 10, then I would set it to more than.
10, 10 is not your solution. You have to pick inside your solution region.
Oh, okay.
Yeah. All right. Anything else, Michael?
No, I'm good, thanks.
All right. All right. Okay, so let me take a look at the practice exam. I kind of wrote your exam 3, but I think I'm gonna make some change. Come on, come on.